Okay, in this presentation we are going to look at second order ODEs. Now we're going to sort of ease ourselves into it. So essentially the main thing we're looking at here is solving the general solution, okay? And that really means just actually getting the auxiliary equation and just setting up a general solution. So, as always, essentially the first thing we do actually with these sort of equations is to actually set up the auxiliary equation. So we have d squared of y over dx squared minus 9 times that, minus 24 times dy over dx plus 16y. Okay, so what we're going to do here is actually write a sort of corresponding equation called the auxiliary equation, okay? So essentially what we do here for second order expressions here, we just substitute in m squared. First order, m, and just y or whatever that is, y or x or whatever, just take out the coefficient, okay? So we have 9m squared minus 24m plus 16 equals 0. So this is the auxiliary equation, and okay, so essentially what we have to do is solve that. So we should get two expressions there. Well, actually we won't in this case. We actually will get one, okay? So I have these out of order, it seems. Okay, so if you factorize that, you should find that it is a square. So we get 3m minus 4 squared, okay? And so therefore, m is equal to 4 over 3, as in we have repeated roots or double roots, okay? So we don't have two distinct values. We got one single value that gets repeated, okay? So that's a sort of special case. So there's three special cases that you will encounter here. This is one of them. Okay, so the general solution in this case is a plus bx, okay? So y, by the way, just actually let's keep an eye on this. Y is a function of x, okay? So just actually, where is this, so we can keep track of that, y and x. So essentially what we want is y as a function of x, okay? Because these can change around. This can be x over t, or y over x or something. Well, it is y over x, but so watch out for that, okay? So essentially in this case it's y as a function of x. So here we have y equals a plus bx times e to the mx, okay? Now a and b, as far as the general solution is concerned, are undetermined coefficients. Now you can actually find them out when you get boundary conditions, but essentially that's not part of what we're doing here right now. We're just going to ease into this slowly. So just for today, just for this exercise, a and b will stay as a and b. Okay, so essentially what we have to do is essentially just substitute in m here as 4 over 3. So that is actually our answer. Y equals a plus bx times, let's just put that in brackets, times e to the times e to the 4x over 3. Okay, so that's the answer to the first one there. Okay, so let's just set up the second one now. Okay, let's just sort of get set up here again. So obtain the so this is the second one. Okay, obtain the general solution of this. So here we have 2 times d squared of x over dt squared. Now remember, x in terms of t here, okay, minus 7 times dx dt, or dx over dt, plus 3x equal to 0, okay? So again, what we do here is we start off with the auxiliary equation. So for the second order term here, we replace that with m squared, or write in m squared in correspondence to it. So we have 2m squared, don't forget that coefficient there, minus 7 times this first order expression here, so we have minus 7 times n, plus 3x, so that just write in plus 3. Okay, so what we do here is we factorize that. Solving that, we get 2m minus 1, and m minus 3 is equal to 0, or in other words, m is equal to 1 half, and m is equal to 3. So unlike the last one, we got two separate expressions, okay? So essentially the general solution is as follows. Just going to so we're just going to call M1, just assign them names. M1 is this one, M2 is this one. A is an undetermined coefficient. We're just going to leave it as capital A for the time for the rest of this exercise. Okay. E to the M1t plus B times E to the M2t. Okay, essentially all we're going to do here is just put in put in the values m1. So m1 is equal to half, so m1t is t over 2. M2 is 3, so m23 is 3t. Okay, so x is equal to a times e to the t over 2 plus b times e to the 3t. So that is the answer to the second one. So the last one. Okay, so let's just get set up here. Okay, so this is the last of the tree. Okay, so obtain the general solution of the following: d squared x over dt squared minus 2x 2 times dx over dt plus 10x equals 0. And again, the auxiliary equation. So we have a second order expression here. So a second order expression here: m squared minus 2x dt or 2 dx over dt. So minus 2m plus 10x. So we get plus 10. Okay, so can we solve that? Well, essentially, I sort of said earlier on that there's three different ones here, three different sort of variants. Okay, so if you try factorizing that, you might sort of spot very quickly that b squared minus 4ac is going to be b squared that's going to be 4 minus 4 times 1 times 10. So 4 minus 40 is minus 36. So essentially what we're going to have here is complex roots. Okay, so I'm just going to sort of highlight that fact. It's just to sort of give you a sense of what to do, because you should expect these complex roots. So just actually use the formula: minus b plus or minus b squared minus 4ac. And again, this is nothing to do. These numbers here are nothing to do. This is just the general formula. We're going to use a and b separately again later on. Let's just make it all capitals for sake of consistency. And so in this case, what we will get is b is 2, or sorry, minus b is minus 2, so minus b is equal to 2. Okay, so actually let's just sort of bring that down again. So b is minus 2. Okay, a is equal to 1, c is equal to 10. So b is equal to minus 2. That means that minus b is equal to 2 plus or minus square root of minus 36. We've seen that already, all over 2a. Okay, so what we have here is when we sort of calculate that out, we get 1 plus or minus 3i. Okay, sorry, I made that look like a fraction, but it's actually not. What I'm going to just sort of state is we have a real component here, alpha. So alpha is equal to 1. Okay, and a complex component here, beta, which is equal to 3. So alpha is equal to 1, beta is equal to 3. Okay, so we use this in our expression here accordingly. This is the last of the three. So we have x equals e to the alpha t. So we're going to have alpha equals 1. So this is going to be e to the t here, times a cos beta t plus b sine beta t. Okay, so we're just going to substitute in 3. Beta equals 3 here. Okay, so just to so you can sort of see that properly, there is the answer written down there. Letting alpha equal to 1 and beta equal to 3, this is the answer we get: e to the t times a cos 3t plus b sine 3t. And that is the third. That's the complex roots example. Now, so these are long questions, and this is usually the first part of these questions, but it's essentially good practice to get the general solution sorted out in your head first. So we'll leave it there.